Hi there, this is Mr. Sam. I'm going to talk to you about reactivity today. Reactivity, well, reactivity is all about... Oh, that was way too small. Okay, let's do this. That's not what I want. Okay, new. Great. Okay, so if you say that the periodic table looks like this, some of you might say that. Aha! It's roughly what the periodic table looks like. I'm going to tell you now something about reactivity. Reactivity is something that's kind of cool. It's the ability of an atom to gain, I'll use red for gain, to gain or lose, I'll use blue, or lose an electron. Okay, gain or lose. So let's think about gain first. So an atom that's able to gain an electron is going to have pretty attractive properties to electrons that are just passing by. So that looks like, to me, that looks like high electron affinity. To me, that's what it looks like. Remember the trends for high electron affinity? That should be a Y, not an I. Oh, I remember those. Yeah, those things as the most electron affinitive, the highest electron affinity would be not these because these are the noble gases, but this guy right here. This is fluorine. And the least would be down over here, francium. Because as you go from left to right on every period here, these atoms are getting smaller and their effective nuclear charge is getting greater. And as you go up like this, the atoms are getting smaller as well. So this right here, fluorine, should be the highest electron affinity. I believe it is. I mean, I have to look that up. Sometimes the trends vary a little bit, but it should be true that this is the highest electron affinity. So fluorine is going to be the most reactive. It's going to rip away electrons from other atoms, other poor saps that are just sitting by. Oh, you silly, silly lithium. If you're anywhere near fluorine, not fluorium. If you're anywhere near fluorine, let's say, because lithium's over here, right? If you're anywhere near fluorine, fluorine will rip away your outside electron and you will be naked. Oh, lithium's right there, actually. That's beryllium I was talking about. Either one of them, fluorine's going to rip away that electron. Chlorine. Oh, chlorine. Man, that thing is nasty stuff. Chlorine, we use it in swimming pools because it rips away electrons from bacteria cells and it totally messes them up to the point where they die. If you breathe in enough chlorine gas, then the lining of your lungs will start to get melted away. That is nasty stuff. Fluorine gas is what we call mustard gas. It was used in World War I. Again, nasty, nasty stuff. Not good stuff to ever breathe in. Don't do that. It's so reactive, it'll rip away electrons from your lung cell wall. Wow. Okay. So these up here in this region, I'm just going to start shading them kind of reddish over here. These, the highest reactivity is kind of clustered together in this top part of the table over here. So this is very, very reactive because these atoms over here, they love to gain electrons. They're really good at doing it. But that's not the full definition of reactivity. That's just half of the definition of reactivity. An element can be reactive if it loses an electron. So if it loses an electron, well, elements that lose an electron, they have low ionization energy. In other words, it's easy to knock those electrons off of atoms. And the elements that have the lowest, and the lowest over here is francium. Francium has the lowest. Francium, you just sneeze and it'll lose an electron. It's pathetic. So these atoms down here clustered towards this corner of the periodic table, these also are very reactive, but for a different reason. They're not gaining electrons. In fact, they're the opposite. They're losing electrons. So since they're so good at losing electrons, they are also called reactive. So I just wanted to let you know that reactivity is it's kind of a weird concept because it's kind of incorporating opposites here, either gaining or losing electrons. So if electrons are passed about, either gained or lost, then it's a reaction. So the most reactive elements here are in the on the top right and the bottom left. And I think I've got a little graphic for that. It's probably in your, oh, there it is. Ah, there we go. This guy. So they call it non-metal reactivity and metal reactivity increases. So you can see down here, they call it metal reactivity, but it's really just reactivity. We can call it reactivity. It doesn't really matter. They're both reactive. So if you go from right to left, it increases, and you go from top to bottom, it increases, like we said before with this. The blues. The blues, they lose. The gain is the pain, and that's red. Okay, I've made too many videos in a row, right? So if you go from left to right and bottom to top, this reactivity increases, and that's what we see on this little corner over here. So I just want to make sure that you guys have that clear. Reactivity means both gaining and losing electrons, not just one or the other. Okay, good luck.